Good morning, everyone. This is P. Ramarao from Government Polytechnic College, Station Ganpur. Today, we discuss about first year diploma students, first semester, first chapter in chemistry, fundamentals of chemistry. In the chapter, we discuss about fundamental particles, atomic number and mass number. Fundamental particles are electrons, protons and neutrons. Atomic number and mass number are fundamental particles. In the chapter, we discuss about fundamental particles of electrons, protons and neutrons. The fundamental particles are electrons, protons and neutrons. In this hour, we discuss about on the completion of this period, you would be able to know what is an atom, what are the fundamental particles, atomic number and mass number. The fundamental particles are discovered according to John Dalton theory. Atom is the smallest tiny invisible particles, but discharge tube experiment. This one is discharge tube. The conducted by Crook and J.J. Thomson. The discharge tube discovered of radioactivity by Madame Curie indicated that atom is not a smallest particle. Still, many smaller particles are present. Atoms are very smallest particle, but in these smallest particles also present the fundamental particles. Among these particles are electrons, protons and neutrons. They are present in all atoms. These particles are called fundamental particles. The fundamental particles are discovered by John Dalton by using discharging tube. In this tube, we discovered by fundamental particles are electrons, protons and neutrons. electrons, protons and neutrons. What is an atom? Atoms are smallest particle of matter. Atoms are very smallest particles of matter. Atoms make up everything around us. Atoms are very smallest particles. In the smallest particles have high energy. These high energy particles have unstable. These atoms make up everything around us. The atoms are unstable when it is incompleted in its outermost orbital. These atoms are unstable. Which atoms are completed fulfilled in its valency shell, those atoms are stable. The stable atoms are helium, neon, argon, krypton, xenon, radon. These atoms are stable. The stable atoms does not form molecules. Which atoms are unstable? Those unstable atoms are combined together to form a stable molecule. These stable molecule formed by the atoms, which one is unstable atoms, which are present in its valency shell less than 8 electrons. Those atoms are involving in formation of molecule. These molecules are stable than atoms. These molecules have less energy than atoms. These molecules are stable electronic configuration in its valency shell. So, the molecule formed between atoms by the sharing of electrons or transfer of electrons between the atoms to form stable molecule. Elements are only one type of atoms. Element means only one type of atom, like hydrogen element, helium, lithium, sodium, potassium, magnesium. These all are elements. Compounds are made up of different types of atoms, like sodium chloride. This sodium chloride combining of one sodium atom and one chlorine atom. These different types of atoms combine together to form compound. A compound like sodium chloride, it is combined with one sodium atom and one chlorine atom. The sodium and chlorine combine together to form a stable compound of sodium chloride. Like here given two example, one is hydrogen gas, second one water molecule. Hydrogen gas. This hydrogen in its valency shell present only one electron. It is unstable. This unstable hydrogen atom combined with another hydrogen atom to form a stable molecule of hydrogen gas. This molecule formed between hydrogen and hydrogen. These two hydrogen valency electrons mutual sharing together to form hydrogen molecule. These unstable hydrogen atoms, when it is combined with another hydrogen atom to form a stable molecule. In water molecule formed by one oxygen atom and two hydrogen atoms. One oxygen and two hydrogen atoms combine together to form a compound of water. In water present one oxygen atom, two hydrogen atoms. This oxygen valency in its presents 6 electrons. In the 6 electrons, 4 pair of electrons, 2 unpair of electrons. Those unpaired electrons sharing with each hydrogen 1 electron to form a covalent bond between oxygen and hydrogen atoms to form a stable molecule of water molecule formed in between oxygen hydrogen atoms. The oxygen and hydrogen atoms sharing together to form a stable molecule of water. Atoms are very smallest particle of matter. Which atoms are unstable? Those are combined together to form a molecule. Different types of atoms like oxygen hydrogen, nitrogen hydrogen, sodium and chlorine combine together to form compounds. How much does an atomic weight? Atoms are very smallest particles. The smallest particle of atom weight. Atoms are so small that it is impractical to use grams. One atom weight is equal to 10 to the power of minus 23 grams. Instead of atoms are measured in atomic mass units are AMU. It is also measured in A. One carbon atom is 12.0 AMUs and all atoms are compared to this. One carbon atom is 12 grams. This 12 grams is 12 AMU, atomic mass units. And all atoms are compared to this. What is an atom made of? Atoms are made of electron, proton, and neutron. These electron, proton, and neutrons present in an atoms, these particles are called fundamental particles. Subatomic particles are neutrons, protons, electrons. The central part of an atom is called nucleus. In this nucleus, present particles are called nucleons. The nucleons of protons and neutrons. The protons and neutrons present in central part of an atom. The fundamental particles are three: electron, proton, and neutron. The central part of an atom is called nucleus. In this nucleus, particles are called nucleons. The nucleon particles are proton and neutron. The central part of an atom present proton and neutron. The remaining particles of electrons surrounded by electrons around the nucleus. Electrons have a negative charged particle, protons have a positive charged particle. Neutrons have no charge, it is neutral. Atom is held together by the attraction of electron and proton. Neutrons are neutral particles. Neutrons are neutral particles. The central part of an atom present particles are nucleons. The nucleons are protons and neutrons. The remaining particles of electrons surrounded by nucleus. The electron have negative charged particle. Proton have a positive charged particle. Atom is held together by attraction of electrons and protons. Neutrons are neutral charge. Subatomic particles. Atoms are composed of three subatomic particles: protons, neutrons, and electrons. The two important properties of these particles are mass and charge. Mass and charge. The fundamental particles: proton mass 1, its charge +1, neutron charge 1, neutron mass 1, neutron charge neutral, that is 0, electron weight or mass is equal to 1840th of hydrogen mass. So electron weight is equal to 1 by 1840, charge of electron -1, charge of electron -1. The mass of electron is negligible. The mass of electron is negligible when compared to the mass of proton and neutrons. So their mass is not included when calculating the mass of the atom. These subatomic particles, mass and charge. The fundamental particles of electrons. Electron, proton and neutrons are fundamental particles. These fundamental particles discovered charge, charge in coulombs, charge in ESU, electrostatic units, mass in kilograms, mass in AMU, atomic mass units, specific charge of electron, proton and neutron. So, first, fundamental particle of electron. The electron was discovered by J.J. Thomson. The electron was discovered by J.J. Thomson. He was discovered in the discharge tube experiment. He was discovered in the discharge tube experiment. The name electron was suggested by Stoney. The name was suggested by Stoney, but discovered by J.J. Thomson. The electron or negative charged particle. The charge of electron was discovered by Millikan. The electrons are negatively charged particle. The charge of electron is in coulombs minus 1.602 into 10 to the power of minus 19 coulombs minus 1.602 into 10 to the power of minus 19 coulombs. Charge in ESU electrostatic units minus 4.8 into 10 to the power of minus 10 ESU. The electron are negative charge. In this negative charge, generally a given unit minus 1 unit in coulombs minus 1.602 into 10 to the power of minus 19 coulombs or minus 4.8 into 10 to the power of minus 10 ESU electrostatic unit. The mass of electron in kilograms 9.1 into 10 to the power of minus 31 kilograms. The mass of electron is negligible when compared to the mass of other fundamental particles. It is equal to 1 by 1837 mass of hydrogen atom. The mass of electron in kilograms 9.1 into 10 to the power of minus 31 kilograms. Mass of electron in AMU 0.00054 AMU. 54 AMU. Specific charge of electron. The ratio of charge to mass is called specific charge. The ratio of charge to mass is called specific charge. Therefore, specific charge is equal charge by mass. Charge by mass. Charge of electron 1.602 into 10 to the power of minus 19. Mass of electron 9.1 into 10 to the power of minus 31 kilograms. So, the specific charge value 1.76 into 10 to the power of 11 coulomb per kilograms. Coulomb per kilograms. These are properties of electrons. Now, proton. Protons was discovered by Goldstein. Goldstein was discovered by protons. Goldstein discovered the positive ray in the discharge tube experiment using a perforated cathode. These are also called anode rays. They liberated from the gas used in the discharge tube. The positively charged particle emitted in the discharge tube in hydrogen gas is used as hydrogen gases used are called protons. The charge of proton is equal to electron. The charge of electron and proton charges are equal but opposite in the sign. That is, the charge of proton is +1 unit and charge of proton in coulombs plus 1.602 into 10 to the power of minus 19 coulombs and in ESU electrostatic units charge 4.8 into 10 to the power of minus 10 ESU. So here positive charged protons charge plus 4.8 into 10 to the power of minus 10 ESU. The mass of proton equal to the hydrogen atom. The real mass of proton is 1.672 into 10 to the power of minus 27 kilograms. 1.672 into 10 to the power of minus 27 kilograms. In atomic mass units 1.00728 AMU. The specific charge of proton is equal to 9.58 into 10 to the power of minus 10 to the power of 7 coulomb per kilograms. An atom contains equal number of electrons and protons. Now, third fundamental particle of neutrons. Neutrons was discovered by Chadwick based on the studies made by him on the bombardment of beryllium by alpha particles. Alpha particles. It is neutral particles charge is 0. Neutron charge in coulombs 0. In ESU 0. The mass of neutron is nearly equal to the mass of proton. The value of proton 1.675 into 10 to the power of minus 27 kilograms. 1.675 into 10 to the power of minus 27 kilograms. In AMU 1.0086 AM. The specific charge of neutron is 0. These are fundamental particles and its properties. Now, atomic number. Atomic number. What is atomic number? The number of protons. The number of protons are the number of electrons present in the atom is called atomic number. Atomic number of an element is equal to the number of protons present in the nucleus of its atom. The number of protons are the number of electrons present in the atom is called atomic number. Atomic number is denoted by Z. Atomic number was proposed by Mosley. Atomic number was proposed by Mosley based on the results of X-ray spectral studio. X-ray spectral studio. It has given a relation between frequency of X-ray and atomic number, a characteristic property of element. From the atomic number, number of protons and electrons present in the atom. So, atomic number Z is equal number of protons or number of electrons. Some example: hydrogen atomic number is 1. So, Z is equal to 1. Helium atomic number 2. Lithium atomic number 3. Sodium 11. Calcium 20. Iron 26. Zinc 30. These 30 means 30 protons or 30 electrons present in zinc element. Mass number. Mass number. Mass number is the sum of the number of protons and neutrons present in the nucleus of an atom. The sum of protons and neutrons present in the atom is called mass number. The sum of protons and neutrons present in the atom is called mass number. This mass number denoted by capital A. Therefore, mass number A is equal number of protons plus number of neutrons. Mass number is the sum of the number of protons and neutrons present in the nucleus of an atom. The difference between mass number and atomic number is equal to the number of neutrons. Therefore, atomic number A is equal number of protons is nothing but atomic number plus number of neutrons n. Therefore, mass number A is equal Z plus n. So, number of neutrons n is equal A minus Z. So, here given one example: carbon atom, atomic number 6, atomic weight or mass number is equal to 12. Therefore, number of neutrons is equal to A minus Z, 12 minus 6, that is equal 6 neutrons present in central part of carbon. Here given calculation of neutrons. X, chemical symbol of the element like hydrogen, helium, lithium, sodium, chlorine, bromine, anyone. Z indication atomic number, that means number of protons. A means mass number, it is sum of protons and neutrons, therefore A is equal Z plus N. Number of neutrons, N is equal A minus Z, A minus Z. Remember once again atomic number, the number of protons in the nucleus of an atom equal the number of electrons. The number of protons in the nucleus of an atom is equal the number of electrons. So atomic number is equal number of protons or number of electrons. The number of protons in the nucleus of an atom equal the number of electrons in the element. Therefore, atomic number Z is equal number of protons, that is also equal to number of electrons. Number of electrons. Protons and electrons. Once again remember mass number. Mass number. Sum of the number of protons and the number of neutrons in the nucleus of the atom. Mass number, sum of the number of protons and the neutrons in the nucleus of an atom. Mass number is equal the number of protons plus number of neutrons. Mass number is equal atomic number plus number of neutrons. Therefore, number of neutrons is equal mass number minus atomic number. Therefore, N is equal A minus Z. A indication of mass number, Z indicates number of neutrons or protons present in an atom. Therefore, A is equal Z plus N, N is equal A minus Z. Here, isotope of carbon C614, carbon atom, the number of protons 6, mass number or atomic weight is equal 14, A is equal 14, the number of protons indication atomic number Z is equal 6, mass number of carbon that is equal 14, the number of neutrons N is equal A minus Z, A is equal 14 minus Z is equal 6, 14 minus 6 that is equal 8. 8 neutrons present in carbon central atom of isotope of C614. The number of electrons is equal to number of protons. So, number of electrons also 6. Here, the number of protons 6, number of electrons 6, number of neutrons is equal 8 in carbon isotope of C614. C614. Carbon atom. Carbon atom C612. C6 12. The number of protons is equal to 6. The number of protons is nothing but atomic number. Atomic number of carbon Z is equal to 6. The number of protons is equal to the number of electrons in an atom. So the number of electrons also 6. The number of neutrons present in carbon 612, N is equal to A minus Z. A is equal to 12, Z value 6, 12 minus 6, that is equal to 6. In carbon 612 present fundamental particles of proton 6, electron 6, neutrons also 6. Here already we discussed C6 14, number of protons 6, number of electrons 6, but here different in number of neutrons, that is 8. Now N714, N714, nitrogen 714. The number of protons Z is equal to 7. Number of protons Z is equal to 7. The number of protons Z is equal to 7. The number of protons is equal to number of electrons. So number of electrons also 7. The number of protons 7. The number of electrons also 7. The number of neutrons present in nitrogen is equal to A minus Z. The number of mass number of nitrogen or atomic weight of nitrogen is equal to 14. Therefore, capital A is equal to 14. The number of neutrons is equal to A minus Z. 14 minus 7, that is equal to 7. The fundamental particles of protons, electrons and neutrons, same number of 7 present in N714. So, calculation of number of fundamental particles present in nitrogen, proton 7, electron 7, neutrons also 7. Here another example, calculation of number of neutrons present in uranium. How many number of protons and neutrons are there in an atom having A 235, A 238 when Z is equal to 92. Uranium 92, 238. Given data, mass number of uranium A is equal to 238. Atomic number of uranium Z is equal to 92. This uranium atom, the number of protons how much, number of electrons how much, the number of neutrons how much. So the number of protons Z is equal to 92. Z is equal to 92. The number of protons is equal to the number of electrons. So electrons also 92. The mass number of uranium A is equal to 238. So the number of neutrons N is equal to A minus Z. N is equal to A minus Z. N means the number of neutrons, A value 238, Z value 92. So the number of neutrons N is equal to A minus Z, that is equal to 238 minus 92, that is equal to 146. 146 of neutrons 92, protons 92, electrons, mass number of uranium 238. So the number of neutrons present in uranium 92 238, that is equal to 146. Atomic number is equal to proton, the number of protons is equal to electron, so the number of neutrons is equal to A minus Z 238 minus 92, that is equal to 146. 146. On the completion of this period, you would be able to know about what are the fundamental particles present in an atom. The fundamental particles are electron, proton and neutrons. What are the charges, mass of fundamental particles, specific charge of fundamental particles discussed in this hour, and also we discuss what is atomic number, what is mass number, how to calculate the number of electrons present in an atom, calculate the number of electrons present in an atom, and also how many number of neutrons present in an atom by using mass number and atomic number. Therefore, number of neutrons n is equal A minus Z. So, on the completion of this period, you do calculate the number of neutrons in this hour. Thank you once again. Thank you.